Hey. Let me ask you a question. Is variation a good thing or a bad thing? Variation is a good thing. Variation is a bad thing. Okay? Not good. Because it means that when it is big, it means that yi lie apart so far away from y bar. When they disperse, the data will be dispersed. This is your first time in class. And then you're slowly. Are you relation them right? Are you one of the what? What? Oh, you are late. Okay, so variation is the best. Okay, whatever, good or bad. I can decompose the variation into two parts, the yellow part and the green part. Okay, variation is the best thing. If you would have a boyfriend, if you have a boyfriend, you want him to take over all your trouble or most of it will be your trouble or your trouble. If you have trouble, you want to have a boyfriend that take over the most of your trouble over little of your trouble. And solve all your trouble, right? Understand? So if you introduce a regression, you want the regression take over the most part of the variation or the little part of the variation. This is the variation without regression, and this is the variation decomposed into two parts. Okay, and one of them is the variation explained by the model. You fit. That's your goal. You want him to take over most of the variation or little of the variation. Your model can explain, can take over most of the variation, right? Understand? Like you look for it, right? You want him to solve all your problems. Understand? So regression is your equation. Understand? Like you want the regression line can explain or can take over all the most of the more the better. Okay, the most of the total sum of the square. So which one, the green part or the yellow part? Which one is the variation explained by your model? Which one? The yellow one or the green one? Oh, sorry. This there should be a hat here. I think it is the green one. Yeah. Yeah. Because white bar is still here. And it was yi without head. Now it is yi with head. And this one is the predicted value of y using your model. Okay, so you want this green part to be the more the better. Because this is the variation explained by the model you fit. Hey, this is predicted by your model. Understand? This one is the distance to y bar. Hey, this is also the distance. Hey, this is the distance to y bar, and also this is also the distance to y bar. And this is the distance without introducing the linear regression. And this is y hat. predicted by your regression. Okay, now the regression line is introduced. Okay, so you should, the green part, if the green part can take a more portion of the variation, then the regression will be better. Okay, because it take over more trouble of why, like your boyfriend, he can take more of. If you can take more of your trouble, then you will. He is a better boyfriend, right? Okay. So the green part, hey, distance to y bar, distance to y bar, and this is the distance without regression, and this is the distance with regression. Understand? Why? Because this y I have, and this is y I have here, predicted by your line. This line, this line, this line, okay? Understand? So this part, okay, the bigger portion of this part, the better. Okay. So, and this is arrow's sum of square. This is, and this is SSE, and this is SSR. So plus. So here we have an indicator. Remember the question? Is there an indicator? Now we have an indicator. Is there an indicator that measures how good the line fits the data? The answer is yes. And now we have the indicator by the ratio. Okay. Yeah. This is the first term is trivially simple, always simple. Okay. And this is the yellow part, and this is the green part. All right. Okay. So, and this part is called total sum of square, and this is called error sum of square, and this is the regression sum of square. Okay, for short, it is SST equal SSE plus SSR, where SSR is the portion. Hey, the portion, the trouble taken by the portion of total variation of yi explained by the physical regression line. The larger portion, the better. Okay, so if you calculate the ratio, you will see how good the your regression line fit the data. So it is SSR divided by SST, and SST is always bigger than SSR, and they are always positive. So the value will always lie between 0 and 1, 0 and 1. Okay, because the lower term is always bigger than the upper term. Okay, and if you can remember, which one is the A? See this? SSR here, SSR here, SST here. Hey, they both have Y bar. This is Y bar, and this is Y bar. Understand? Understand? You see this? Y bar here in the upper term, and also Y bar here in the lower term. All right? See this? And now, this is the variation without regression. And this is the variation calculated by the regression. With your after your regression. And this is the height of yi predicted by the straight line. By the straight line you fit. So they both have y bar. So if in the final exam, I write this I from 1 to n, yi minus y bar square, I from 1 to n, yi minus y hat square. Is that correct? Hey, the benchmark is the white one. Yeah. correct? No. But which one? How to memorize? Is there a trick to memorize the formula? Yes. Why? The one with two white bars is correct. Understand? Understand? This is not correct, well, because there is only white bar, or only one white bar. So I have to wipe this off. This is incorrect. This is incorrect, so I have to wipe it off. Right? Let me wipe it off. Right? Understand? So and it is always between line between it is always lies between 0 and 1, and it reads R squared. No Chinese, sorry. It reads R squared. Called R squared. Understand? Right? Yeah. 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 Here. Okay. And what is this for? What is this page for? Hey, you see this? R squared is defined by the ratio of SSR and SST. And what is SSR? SSR is the upper term, SST is the lower term. And we have a formula for the upper term. And this is the y hat, the formula for y hat. Hey, you see this? Hey, you see this? Hey, you see this? Hey. You see this? Yi equal b plus mxi, right? And now you have this is model assumed. And y hat should be equal to b hat plus m hat xi. And this is model estimated. All right. One is the model assumed and one is the model estimated. So y now it is replaced by b hat plus m hat xi. So it is m hat xi plus b hat. So minus y. But what is b hat? What is b hat? This is b hat. This term, it is b hat here. This is b hat. And so is this. This is b hat. Okay? Right? B hat. This is b hat. And if you replace b hat by this formula, hey, remember this formula? The previous hour? This is the formula for b hat. Okay? And hey, what is this? This is white bar, kick out the other white bar. They kick out each other. Okay? No white bars anymore. No white bars. And they have m hat in common. Okay, m hat xi, m hat x bar. So they have m hat in common. So take it out. So take it out, and don't forget to square m hat, because there is a square sign here. So it is m hat, and it is a xi minus x bar sigma I from 1 to n, and this is yi minus y bar squared sigma I from 1 to n. But what is m hat? And then we have a formula. Remember the formula for m hat? 3x and 1 1. Remember? 3x and 1 1. So now we have, this is the m hat. This is the m hat squared. This is the m hat squared. Okay? So, remember 3x, 1x, 2x, 3x, and 1 y here. And don't forget to square them. So we have a square sign here, and we also have a square sign here. Got it? And now, this is xi minus x bar squared, the same as this one. All right? But there, the power in the lower term is 2, and the power in the upper term is 1. So the power 1 kick out each other. So what is left in the lower term is power 1. It still has power 1. Okay, so it is, what is it? What is it? So it is. So what is it? It is the upper term squared, and not anymore, and the power 1, and this thing has power 1. Okay, and the next page. So we have, what we have here is, hey, the upper term squared, and power 1, xi minus x bar, yi minus y bar, okay? And if you reflect the left term, you obtain this. Okay, power 2 here, and what is the blue part? The blue part with power 2? What is this? Raise your hand if you know the answer. The answer is right below the correlation coefficient. And it is going to appear in the final exam. Understand? So what we have here, what we have here is the conclusion here is R, and the R square is the coefficient of determination. Hey, R square, this is R square. We have a name for R square. It is the coefficient of determination. R square is the coefficient of determination. Okay, and what is the relation? What is the relation of R squared and Rxy? Hey, is R squared equal to capital R squared? The same. Now, R squared equal, for example, R squared equal 0.49. Then what is Rxy? Should be also equal to 0.49. So Rxy is plus or negative. So it is, it should be 0 plus or negative 0.7, right? Tell me how to determine the sign. Positive or negative, which one? There is only one correct value. Raise your hand if you know the answer. If you can answer, I will give you 3 extra bonus in your final grade. Three extra bonus. Final grade. If you know how to determine the sign, then you are excellent. Okay. The answer is as follows. Yeah, this is okay, their relationship. Okay, so if R squared is closer to 1, the regression line fits the data frame. Understand? And what about Rx? If Rxy is closer to 1, negative 1 or positive 1, but it is squared, and it will be very close to 1. Okay, but it is closer to 1, the linear association between x and y are stronger. Is stronger, not are is stronger. Is okay. Is stronger. So that's our conclusion from R squared and capital R squared and the little r squared. Okay, one is the correlation coefficient, and the little one is the correlation coefficient, and the capital one is the coefficient of discrimination. This is from the regression, and this is not from the regression, just from the data alone. Okay, but they are so closely related. And now, how to determine the sign? I have a question. What happened to my mouse? Hi. Hey. Yeah. My mouse. Yeah. Here, moreover. Hey, next conclusion. Hey, you don't worry about you don't worry about the calculation. Hey, all you need to do is to look at f equals Rxy as x as y. Okay, and now this is Sx is this one. This is Sx, and this is Sy. Xy is this is Xx, and this is Xy. Okay. This is Sx. This is Xx, and this is Xy. Okay. Hey, look at it. They are all constant. This is constant because every term is a square, so it is always positive. It's always this. It's always this. Every term is a square, so the sum is always positive. So this one is positive, and this one is positive. And now m hat is equal to Rxy times Sy divided by Sx, where the last two terms are all positive. So what is your conclusion? Little r and m hat should have the same sign. Either they are both positive, or they are both negative. Understand? Okay? What is the conclusion from this thing? What? Yeah. Little Rxy and m hat must have the sense. They must be both positive or both negative. So if you want to tell the sign, if you wanted to determine the sign, just look at it. If you wanted to know the sign, just look at the sign of M hat. If it is positive, then so is Rx. If M hat is negative, then so is Rx. Understand? You see that? So here, I will wipe this off in the exam. I will wipe this off here. Here, I will wipe this off. Hey, this is our square. Here, this is our square. Here, this one. And I will give you this. So what is the value of Rx, little Rxy? What is the value of little Rxy? Little Rxy, Rxy equal the square root of R square equal the square SQRT. This one. Okay, so what is it? Hey, 0.67173. This is the Rx. Okay, important. I said it is possible. Why? Because it has the same sign as M hat. So where is M hat? Here. Is M hat? This is the M hat. Is this positive or negative? Positive. So this should be positive. Hey, positive. M hat equal 0.67318. Okay? Understand? In the exam, you will use this to calculate the value of Rxy and determine the sign, positive or negative. And then you should determine the sign based on this cell. Here, this one here. One here. Okay? So, because this is positive, so Rxy equal should be also positive. Okay, this is the first question. It's okay to you, right? Just calculate this square root. What if I wipe this off? What if I wipe this off? What if I wipe this off? Like in the exam, I will also wipe this off. I will remove this step. I'm causing you trouble. And you have to solve the problem yourself, not your brain. Okay? I will remove this step. When I will remove this step, how to recover it? How to retrieve balance? Yeah, you tell me. What? You don't know? The answer is here. You see this? What is this? This is SSR. This is SSR, and this is SSE. Okay, so this is SSR. This is SSR.
Here it is SSR. And what is this? This one, it is SSE. So this is the green part. I should use the green color. This is SSR. And this is the yellow part. I should use yellow pen. Yellow. And this is SSE. Okay? Understand? And SST is the sum of SSR plus SSE. Okay? So if I write them off, then you cannot. So this is R square here. R square is equal to SSR divided by SSE. So it is C12 divided by C14. Divided by C14, 1/4, C14. You see that? Okay. So what is it? Hi. It is 37 divided by the total sum of square. Right? See this? So if I want 10 more, and you just calculate the ratio, then you will obtain a square. Okay? Yeah, use your calculator to see if it is the same as calculate. What is it? Then, what is the ratio? Four, 5, 1, 2, 1. 4, 5 equal. Okay. 0.45. And let us go back to the PowerPoint. Let us go back to the PowerPoint. Is it 0.45? Yeah. What? Equation number? What equation number? Equation number? What? That's the formula. That's the formula. C12 close to column C and row 12. And C14 column C and row 14. Yeah. I cannot give what it. On the same board, the formula is in the previous pages. Here. This is the formula. The formula is here. Yeah. Yeah, this is the formula. R squared. That's the formula. And it is SSR divided by SST. Yeah, that's the formula. What? Yeah, that's SSR. You mean here? Here? I can sell. Oh, sorry. That's a typo. Sorry. Yeah. Right. So, the value here should be 0.4512. But this one can be calculated by SSR divided by SST. And the result here is 0.2512. All right. And here. So let's go back to the page. Is that here? Yeah, here. Hey? Where is it? Yep, this one. Yeah. You see this? What is the number here? 0.4512. The same? Yes. Is that the same? Is that so? The same. And this is calculated by Microsoft Excel. And here it is calculated by yourself. If I wipe this off, hey, is it the same? Yes. Again, I will also wipe this off. Sorry, I will have to also wipe this off. Sorry. You did this. Hey, you did this to calculate the value of R squared, but it is not available in the exam. You have to restrict it. How to append it? Because this plus this is this. You can use this minus this to append it. So in the exam, and let me tell you how. In the exam, hey, don't look at yourself all the time. I'm gonna give you the hint. Okay, number one, in the exam, I will wipe this off. And this value should be retrieved by this minus this. Right? And when you have this, this is the SSR, and this is SST. So when you have this, you divide SSR by SST to obtain R squared. To obtain R squared here. Right? And then when I ask you, when I want you to write the value of Rxy, then you take the square root of B5. It is the square root here. Our little Rxy is the square root of this one. And then you have to determine the sign, not positive or negative. And then what should you do? What should you do?
Look at this one. There is no negative. So this one is positive. The sign for this one is positive. And n hat, this is the where n hat is. This is n hat. N hat has positive sign. Then so is our x bar. Understand? Understand? This is what is going to appear in the final exam. Hey, repeat again. Let me repeat again. I will wipe this off. And this can be retrieved by this minus this, this. And then when you have this, you divide this term by this term, SSR over SST to obtain R squared. And when you have R squared, then you can calculate, you can obtain the square root of R squared. Okay, which is our little RXY, the correlation coefficient of power Q3. Power Q. Okay, this one. RXY is developed proposed by this one. Okay, and when you have RXY, then the last thing you need to do is determine its sign. Its sign is the same as exactly the same as this one. The sign of this one. Okay, now it is positive. So what is the sign of RXY? You know RXY. Also positive. Okay, that's what is going to appear in your final exam. Understand?
And I will also wipe this off. I will also wipe this off. I will be back for it. Okay, and now here. Here, and here. Okay. Okay. Now,
I wanted to understand
if you wanted to perform the test,
hey, when m is 0, then it means that when m is 0, hey, you remember this formula? When m is 0, this is positive, and so is this. When this is 0, then so is little rxy. Understand? So the strength of linear relationship between x and y is 0. And then the regression line will be flat. When the regression line is flat, it means that there is no linear relations associations between x and y, and that y does not change in response to any change in x. Whatever the value of x, y always remains the same. So they have no linear association. Okay, so you wanted to test. You wanted to determine whether an m is 0 or not. Okay. Okay. So you need to perform the test. Understand? You need to perform the test. So what? If you want to perform the test, you will need a test statistic. So, like other test device here, for example, right? However, in this hypothesis testing, see if m is 0 or positive or negative. Okay, so how to perform the test? Here, the test. This is another regression model. Okay, this is negative. The slope here is negative. Hey, if I give you this, then here this is negative. And so is the sign of Rx1. And you should tell me that correlation coefficient, Pearson's correlation coefficient, the sign is negative. Understand? Because the slope is negative. And if you wanted to test, and this is a tutorial test. Okay, the test statistic here is m hat minus 0, and 0 is the value assumed in the null hypothesis. Here, the value 0 is assumed in the null hypothesis. Okay, and it is always here the standard deviation of the estimate. So, what is the standard deviation of m hat? Here, you see this standard error. This is the standard error, and this is the m hat. And this is the m hat here, minus 0, and this is the standard error, standard deviation, standard error of m hat. So if I write this off, then you divide this by this, and you will obtain this. Okay. Let us try it. Here, it is going to appear in the final exam. Hey, what is the value here? Copy, paste. Okay, so I'm in the exam. I will remove the value, remove the number. I will remove this number, and then you have to restrict the number by half. M hat minus 0 divided by the standard error of m hat here. Okay, so use calculator to verify. Let me equal. This is B18, B18 divided by C18. C18. Is it 2.56472? Yes, yeah, same. That they are the same. What? What? What is that? You did. You see this? This is the T statistic, right? T statistic is the m hat minus 0. This is the m hat. And this is the divided by the standard error of m hat. And this is the standard error of m hat. So this divided by this, which is B18 divided by C18. Okay? And you will obtain the value. Which is the same as this one. The same as this one. Okay? The same. You see that? Okay? So I will remove this number. And then you have to recover. You have to retrieve the number. Okay? Find it back. How many cells will I remove? Now at least 4. Yeah, 4. Yeah, and they will be filled in the next week. Okay? Okay, see you next week.
The roll call. Second one is 7. 3 seconds, 4 seconds, 5 seconds, done. So many absolute stupid. Yeah. Yes.
You have a class on this thing.
Yeah. What?
I didn't know you had a class on this.
What? I don't know why. What happened? I have that's a mistake. So, yeah. What means it? What is your seat number? Ten 什么？哎，这是 B head， 这个是 M head， 这个是 B head。对对对对。对，线性关系的强度，哎，回归那个线有没有贴近那个点？点有没有贴近线？点越贴近线，那个 R 会越大。哎。Yeah, I recorded. Yeah.
So is it fine for me to just record it for only 1 hour because I was absent on the last hour? So there's no recording on
The first hour, no. Sorry. No.
I'll upload it, okay, for the 1 hour.
What?
I'll upload it to the YouTube. This one.
Oh yeah, sure.
Thank you, sir. So do you have a picture of yourself, sir?
Picture?
Yeah, of yourself.
My picture. Why?
I want to make a thumbnail.
What?
I want to make a thumbnail.
Thumbnail. What is it?
YouTube.
Oh no, I don't need that. No, I don't want to expose. 小 r 就是开根号啊，开根号之后就是小 r 啊，但是它有正负号的问题啊，开根号有正负号的问题啊 ，m head 怎样？哎，对，它用在没有了，当然它有 m head 有它自己的意思嘛，但是你要找小 r x y 的正负号，去看 m head，对。你说怎样？啊，大 R 平方一定是正的，那没有问题啊。小 r 是它的开根号，但是它开根号就有正负的问题嘛。那你要看正负，就是看 m hat。
对，
是这样。
大 R 跟 M hat 没有任何关系。
没有关系啊。
OK。哦，
当然你说要有关系也是扯得到啦，但是没有那么直接啦。
这边跟这边有关系。
对。
这边跟这边。
哎，对。哎，对了，这样对了。